Hi everyone, thank you for being to this workshop that we'll give with Sebastian Bodenstein that is here. So the title of the workshop is Building Smart Applications That Learn. Mainly we'll build smart applications and a bit of applications that learn as well. So there's really two things. That's smart applications, things that can take natural language input or that can use our built-in capabilities in machine learning. And then some application that you will use the learning function of Mathematica to create an application. And in the end, I might demonstrate an application that actually learns as it goes on the cloud, but I think that for 1 hour workshop, it may be a bit hard to code that yourself. So this I will just demonstrate. And what we decided to do is to have a bunch of exercise. So I don't know, 5, 6 exercises, something like this. And a simple project. And as we wanted to have as much fun as you, we actually did not complete this project. So we'll see how it goes. But it should. I mean, we hope it should work. We can take that as a challenge. So I think the idea is that I give you the goal, the challenge, and you can try working on it. And as it goes, maybe we can pass by and give more and more elements to help you. And in the end, we just show how you could do it. I mean, one way to do it, because we're in the same boat as you here. We haven't done them. OK, so the first one would be to create a web app that, if you give the name of a city in natural language input, it shows you the population of the city. All right, so you have to figure out yourself how you could do that, look in the documentation, how do we do a web app, how do we go from natural language input to a symbolic representation of this input. And all right, let's go. So an example would be if I type Paris, it will actually give me the population.
Okay, yeah, that's pretty easy.
Okay, and so a few hints. You probably have to do a form function, which is something to deploy. When you have Wolfram language code, you can use a form function to give an input, and this input can be interpreted. This function has been done, like the backbone of this function is interpreter, which is a tool that has various types, and you can interpret countries, street address, animals, all sorts of things, including city. And if there's bad internet, there will be a problem. Does everyone have internet? Oh, God. That's a good thing to do, a workshop about building web application without internet. All right, and the second tip is to use cloud deploy, which is a key function to deploy your Wolfram language into the cloud. Okay, we'll see. All right. So did you guys have a solution? Do you have something that works? Or some of you? Maybe we can start giving some elements. So, OK. So you have to use a form function. And let's see how form function works. So we go in the documentation. Let me put that bigger. And if you look at the specification here, like the most basic one, usually on top, has two arguments. The first one is a form specification, and the second one is a function. So the form specification, we can look at an example, and actually it's I mean, it's not the perfect example, but yeah, you have a list, and each element of this list corresponds to one field. So let's copy that one. I think that's always a good idea too. That's quite classic. Go in documentation, copy an example, and then you modify it. And if I do that, it creates a form that has, okay, two field. We just want one field. And what this means is that on the right part of the rule, it means that the input will be interpreted as a string. And on the left part, it's the name of the input that you can see there. So then you can use this name, use this syntax. So this is a pure function. Sorry, first. It's a pure function that will, so f will act on, what do you call that, hash first, right? So if I submit, I can try it. It should return f of this, okay? So that's here where we're going to put our function. So the first thing to change is that it's not a string we want, it's actually a city. So now the interpretation will be done automatically. If I put something, it will interpret as a city. And then we want to do something on this city. So instead of deploying right now, I'm going to try things with interpreter. This is really what's underneath the form function. So if I do interpreter city and I type Paris, we'll see how it works. I hope I have actually, maybe myself, yeah, I have internet. Maybe, you know what, I will. Because I had problem with entities, I don't know why. And if you do that, it should output an entity. So it's our way to representing all this symbolically, all these concepts. So this is a concept of Paris, the city. It's well defined. And then we can ask, OK, what kind of properties can we ask to Paris? So we type properties, and you have a bunch of properties. And in these properties, you can find city population. I guess only population might work as well, right? I mean, no, exactly. It's entity property, city. So this is just a display, this orange stuff. The code underneath is entity property, first argument city, third argument population. And that's the way that we kind of harvest all the knowledge that is in the Wolfram language that comes from Wolfram Alpha originally. That, there have been a lot of curators that put all this data. And so instead of properties here, I can just put city population, and it outputs city population. OK, so let's do the function now that outputs city population. Actually, it's quite direct. So it will just be first city population. OK, it takes the city, he asks for the city population. And here I have the form, and I can actually try it offline. And if I do Paris, it should return the population. It worked offline, and now let's deploy it. So, all right, what does it work? OK. And so I'll just do cloud deploy. OK, my computer lags a lot. I have no idea what's happening. This is very weird. Let me. OK. So you do cloud deploy, and it will output a URL on which you can go. So, OK, I have no idea what's going on. I think I'm going to quit the kernel. OK, that's always a bad, always embarrassing, but this happens. Huh. All right, so the cloud deploy, we create a website, okay, a web page, and you can go on this web page and run the function. So, OK, let's try again. No, it was not the kernel. It's actually super slow still. OK, I'm going to restart. What?
My connection keeps timing out. Same here.
Really?
I guess if everyone's trying to do it, it's not a surprise.
The same thing at the same time. OK, OK, let's. I'm going to. I don't think. I mean, me was not the bandwidth. Me was just. I don't know. My computer to just get crazy. Here we go. All right. Okay, that's much better. So I do the form. Build dynamics. Okay. I hope that. Oh, it's still very. What's going on?
That same thing happened to me. I fixed it by just assigning form equals that and semicolon.
Oh God, this is the display that's a problem? Oh God. You have to tell that to Carlo Barbieri and Ricardo. Okay, yeah, okay. Okay, let's do this. Oh, now it's, oh God. Okay, it's back to normal. Okay. All right, and now I can cloud deploy this form, and I have URL, and I can click on it, and to test this this website. And one thing that you should do, I mean, not you should do, but it's often to put permission to public. I mean, this is to allow everybody to use your URL. Which, when it has a name like that, you're pretty safe that they won't ruin your cloud credits. But it's useful because sometimes you want to try it on another computer that when you're not connected to the cloud. And I think you're right. The network is pretty bad. OK, next year we have to do workshop in a place where the network is good. Because workshop needs internet. OK, first. And now, OK, what do we try? Chicago. What? Yeah, no, I'm not that. Do I spell Chicago right? I mean, you see the small spiky because it's a smartphone. It's because it interprets a type that is not a string or a number, like something a bit more fancy. So there's a little spiky here, and it should output the result. Okay, on a normal network, it goes fast. You have to look in the properties. I don't know all the properties, but there might be some properties that just take the inside area and so on. And OK, that's a bit weird. So actually, it should return a quantity because it should return a Wolfram language thing. And the way to OK, I'm very sorry. This is very annoying. That why doesn't it return anything? Okay, so let's try something. So if you put a third argument, a form function, this will tell the format that it will be converted, so it will be exported to the web page. And so maybe there was a problem with the format it was exporting it. So I'm going to try again. Although I think it's just the network. So here it should actually display the quantity in an image. And OK, here you go. Here you have the result on top. I don't know if you see, or do you? OK, that was the result. So it rasterized the expression, and it put it in the website. So 2.7 million people. OK, let's move on. We have some more exciting ones. Maybe this one is not as exciting as Sebastian was telling me. So maybe we can do it quickly. It's how to take natural it's interesting. So it's another way to input natural language. That allows to input a bit more complex natural language than just the interpreter type, which is just like you put a city, you put a country, you put whatever. Here you can actually put a sentence. And we have tools to interpret a sentence. And that's actually the same tool, I mean, very similar that I use for Wolfram Alpha. So the question is, create a function that multiplies two numbers when you gave this number in natural language. For example, you say, multiply 3 and 4, like that. And this should work. Okay? And to be simple, let's always use this way, like multiply first number and another number. And to it's to m at grammar. Okay. And you should look at the function grammar apply to do that. And so I'll let you 3 minutes, and I will do it to go to the a bit more exciting examples. Okay, I think I will do it because as soon as you go to grammar apply, the first example is is the same. So let's call it multiplication, but then we will try to understand what's in this example. Okay, so it uses grammar rules. Grammar rules define some kind of pattern on the natural language. Okay, such as you have pattern for Wolfram language expression. This is some pattern for natural language, and here says fixed order, so it just means that the patterns you cannot actually put them in any order you want. And the first word has to be add, but it has to be multiply. Okay. The second word, the second token, will be interpreted as a semantic number. So it uses interpreter again. Like all these things on the bottom, there's always interpreter. So it will interpret this token as a semantic number. Okay, then it has to have an end in a sentence, and then the second number will be again interpreted as a semantic number, and then this operation will perform. So as it's A times B, and you have to cloud deploy that. And fortunately, grammar rule doesn't work if you don't cloud deploy it, and then you have to use grammar apply. So you have a cloud object, and you use grammar apply on this cloud object with whatever you want to do. So for example, what do you say? Multiply 7 and 123. Okay, and let's see. Probably worked. I guess 7 times 123 is that. And I mean, put 7 times 3, then everybody will agree with me. Okay, it's a slow it's a slow computation, but okay. So this uses okay, 21. Okay. That worked. So these things are useful for you to define. When you're in a small set of sentence, like for example when you control your house or stuff like that, you always say the same things. Turn the heater on, turn the heater at this temperature, turn the oven on, turn the light of the kids, whatever. And this you can put a bunch of rules. It won't be that long, and it will do the job. And when you add it with speech to text that Sebastian is working on right now. It will allow you to have, put a small Raspberry Pi in your home, and then you can just speak, and things happen. And so it's not the smartest thing in the world, but it's useful. And actually, that's how Wolfram Alpha is done. So it gives you an idea of how it can extend to more complicated things. OK, let's do something more fun now. So the idea here is you have to do a web application that finds what among the famous person of our world that we all love and care for. Which one is your lookalike? Okay, which is your famous doppelganger? So you have to find that, and you have to create an application that does that, and then that displays a picture of you, a picture of the doppelganger, and the name of the doppelganger. And then you have to try it on your phone. That's the task. So, I have to give you one hint, is that to find which is your doppelganger, you have to use a built-in classifier, notable person. Otherwise, I guess it would be hard to find documentation. And the second argument, you put your image, and it should find And by the way, if you manage to do this application good, I think it can become viral. Just put it to your Facebook friend, and they are sharing, and you're like, oh, I look like him. He's so hot, and you know. Anyway. I tried. It doesn't work for me. I'm either Manny Pacquiao or some guy in some TV show. Yes, that's a very, very good point. Basically, two ways, because the URL are like this. So there's two ways to put it to your phone. Either you email it to you, or I don't know, in some way, or you use URL shorten. Indeed. And I think you can put that directly on the cloud object, actually. It will work as well. It can either be a string that represents a URL, or the cloud object, and it will have a much tinier URL that you can type after. So yeah, if you try it on your computer, you should be able to do current image, although I think if you have Linux, sometimes current image doesn't work. It never works, OK. But on your phone, it should always work, because it will ask you to take a picture. Yeah, the first time you use it on your computer, it will be long, it's true, because it will download. So it's a deep neural network that does the job for recognizing the famous person. And it's like 50 megabytes, right, Sebastian? So it might take a bit, but only the first time. But in the cloud, that should already be loaded, so. Hmm? Should, yeah.
Is it? Or is it?
I don't know, we'll see.
I think it's not the
OK. It works in the cloud?
It's rap music, okay?
Ah. Can see that. Oh, we should have done something when everybody could send the results and do a display of everyone,
Yeah.
but anyway.
It uses a gender classifier as well.
Yeah. Yeah. Actually, yeah.
So what you can actually do is, because you can, from the entities of the celebrities, you can
Yeah.
see what their gender is.
Yeah, if you do Eminem. So by the way, if you do control equal, that's a way to get the entity. And and if you look at the properties of Eminem, OK, it doesn't. All right, that's pretty bad. Why doesn't it work? All right.
Maybe your internet's not working properly.
I don't know. Anyway, in the property, you have gender, so you can ask the person. And OK, that's other thing you need to know is in order to get the picture of the person, you have to look in the properties of the entity and find how to get the picture of this person. OK, maybe I can start doing it now. What do we have? We still have 30 minutes, 25 minutes. Oh, we'll a little bit. Wait a little bit. And we'll start doing things that truly learn after. Use Classifier and things like that. I know that some Some of you might have come for that, and the next two examples are about classify and predict.
I need to see how this hacky gender classifier.
Gender classifier might go viral as well, because since it might be wrong 10% of the time, people will make fun of each other. It works with me. Okay, let's try it. So, how do we do that? Again, a form function. So we can take the form function before. Let's be lazy. It never killed anyone. Okay. So I take the one of before. And how do I change that? Instead of calling it first, I will call it picture. And here, the interpretation will be image. Okay? So it will go as an image object in the Wolfram language once it has been interpreted. So then the argument is picture here, right? And I want to apply the classify notable person on this picture. So I will remove this function. I have to keep the a person. That's what tells that it's a pure function. So classify notable person, comma picture. Okay. This would return the entity. And I put PNG to have no problem of formatting, to rasterize, convert to an image, and display the image to be nicer. And but I don't just want the notable person. I also want my picture. So I will put hash picture here. So I just put a list. I don't try to do something fancy with row or whatever. I just put a list. And then we also want the picture of the notable person. All right, so that's where we need to get in the properties. So since we're going to use these things twice, okay, now let's first get the property. So what's famous person? Okay, cool. So then I can look at, I wish I was classified as the incident, but never happened. And then properties. And we look in the properties. If there's one for pictures, I think there is. Otherwise, image, bam. Let's see if it works for Zidane. Right, I guess the image is, yeah. Well, I look like him a bit. No, anyway. And okay, so now this will be the entity. So here we'll just do a module to create a variable. Okay. So okay, as soon as you start doing module and stuff, go into develop a code cell. It's much nicer. So then I will do a bit of formatting. Put module. Here I will put, so this will be called entity that returned by the classifier. So, and then I will compute what this entity is. Okay, here I have the entity. And so I have to put, okay, I have to close the module. So this makes a big pure function. All right, and then I will show my picture, then the entity, and then the picture of the entity. So I just do like this. Image. Here you go. I think this should, okay, minus the bugs. This should work. And I export all that to PNG. Then it will be easier. I'm pretty sure it will work. Like this, let me format up. See 3 arguments, so I put them like this. Anyway. Okay, here is a form, and let's cloud deploy it. Cloud deploy, And I deploy the form, and I will put permissions to public so I can try on my cell phone. I will also print to a variable. It's deployed. And all right, let's URL shorten. And actually, everybody can use that one. But OK, let me try first before. Actually, I mean, let's try like this. If this one is working. OK, and I can browse a picture. And actually, I might have a picture of me. So maybe I can try. Yes, I think head is a picture of me. I hope it is. All right. Oh, I'm John Krasinski again. OK. It's either Pacquiao or Krasinski, depending on the beard. OK. So here it is. Here's the app. I didn't know who this guy was before. Yeah, 2 times out of 3, it's him. Anyway, and so the URL shorten, and so you can try on your phone. And OK, now you know it works. You can all use this one. Since I put permissions to public, now it's deployed. It's a website. You can all use it. You can all, tell your friends. If many people use it, I might put an ad on it and get a bit of money. But please spread the word. But then I have to type. So I don't think I need to put HTTP. So just wolf.am. It's always the same for the reduced URL, and then it's some kind of 7FS ITS RF. OK. What does it? OK. Yeah, the network is indeed very bad. Did you manage to make it work? Yeah, with this address? I mean, for yours, OK. 7FS. OK, good. So it worked, and I don't know if you can. I can show you. I mean, you won't see, so maybe I can do with current image or with dynamic. No, it's a trick to do video. I don't know. I'm going to put the. So, oh dear. What? Oh, it must be. Where is it black? We polarize or something? OK, so it looks like this. OK, and you have a button, and you can click. And then you can do a selfie. And no, this is not a picture of you. OK. All right. So like this, I agree. And I do submit. Click submit. OK, it's submitted. And super bad. What happened? Maybe it's better like this, actually.
What does it say?
I don't know. It's just slow. It's ridiculous. It's to upload the picture. I'm going to remove the Wi-Fi and just go on the. Yeah, I'm going to remove the Wi-Fi and just go on the. All right. OK, I went on the mobile internet. I think it's going to be better than the Wi-Fi. All right. And as you can see, I'm again John Krasinski. So it's kind of consistent. I think it's kind of cool. I mean, to be able to do something like that just in few lines. And honestly, it's something that people will actually like to try. I mean, I like to try it. OK. Cool. Who are you?
She's a guy.
A god. Oh, a guy. Oh, yeah. It happens sometimes. Yeah.
He's Hulk Hogan.
Who? Hulk. Okay.
Oh man.
I would Charles Manson.
Charles Manson. Wow.
I was the Pope.
The Pope. Okay. Okay. We should have done something that your app and send an email to us.
Like a collage. You could
Yeah.
combine it.
Oh yeah, you could combine. Oh, actually, that was anyway. Yeah, you could do like picture and this one. If you want to do image collage, it's another image collage, and it will return something. You next to the other one, or you can. I mean, let's not do it. But you can also, since now we have linked toward like the Bing API for images, for example. You can get 5 images of the guy and putting there, or the girl, or the celebrity, and put them together. I mean, you can do all sorts of things. It can be fun and make it look nice and make it like some people like they're not there. There was 4 students from Michigan University that you might have seen gave talk in this room, and another one that won many hackathon, and they just use our technology, and it looks very nice. Like it's a nice website. They put a good background, a good thing. It doesn't look like, of course, just a stupid list that returns, and so you can play with that, and if it looks good, I'm ready to bet that it will spread. It will spread. All right, so a new one. It's almost the last one. We have 2 more, and maybe I will talk about one, but you won't do it as an exercise. So one is about finding which color, what is the main color in a picture, but finding in an intelligible way. Does it work? Yeah. In an intelligible way. It shouldn't say RGB color 1.3, 3.5, or whatever, okay? Because this is not something a human can understand. So it has to say it's black, it's white, it's red, it's blue, okay? And from a picture. And I mean, I can imagine it's pretty easy to do, but there's many applications for that. Like somebody that is colorblind, and you want to put some things in the morning. And
have RGB, you can just do max on the value, right?
but then it's just RGB. Yes, exactly. So that works with RGB, but and then the person can take it in its cell phone, and take picture, or maybe somebody blind, but it will have to speak, of course, and it says blue, red, and then it can, Or when he's buying, because I guess the clothes you know the color they have, but when he's buying new clothes. All right, so the idea is to take a picture, find the dominant color in this picture, and then convert this dominant color to a label. And for that, you will need to use machine learning. It sounds like a stupid thing, and you may say, why do I need machine learning for that? But if you think about it a little bit, like what is red? What is purple? What is the definition of these things? If you have a nice mathematical definition for these things, if I can give you 3 numbers of RGB, and you tell me, oh yeah, this is purple, right, you could use it. You could have a bunch of heuristics. But in practice, it's more complicated than that. Like there's some boundaries in this 3D space that are nonlinear. And so, I mean, you could be an expert in color and maybe write a code for that, like a classic code. But since I'm not an expert in color, I should ask the image people maybe. That would be a good challenge. Try to do that actually without machine learning. So one thing to do, so just to give you a lead, is that you have to get examples. So, first you have to do the ontology. Define the colors that we want to classify. Okay, let's do that together, because otherwise, so I don't know if you do color. Yeah, colors. Okay, there's a guide there, and you see it as name colors. So we're going to use these named colors. Okay, so for example, let me reduce the screen. Let's do the ontology right now.
You can also use the RGB, the web colors as strings.
Web color strings, what is that?
I think in 10.2.
What do I type?
I have to check for that. You can do RGB color and type as a string the RGB name. I'll find it.
Okay. Let's do like this. So let's do, okay. So if I type red, it actually represents the red. So it's RGB underneath. You see RGB color. So this one will have the value red. Okay. This will be our first example. Let's construct the other one. The other one. So let's do green. So basically it's just doing that. Green, and then what is that? Blue, blue. Okay, so I'm constructing a data set, and black goes to black, and okay, not very efficient what I do, but can I do this without typing everything?
Yeah, you can map the two expressions.
Yeah, but look at what it looks like. Okay, at least I can do some, at least I will copy all this like this. Huh? Pink, purple. And what do we have? From yellow to, we had black, so white. Okay, let's do that. I will have white. I will have gray. Gray,
So you can
cyan.
do RGB color and inside write any valid HTML color name as a string.
Okay.
So you can just get the list of which I don't know what.
I want all list. Okay. My problem is to get the list because once, indeed, I can do two strings. Oh.
Just make it all with strings.
Yeah, no, but it will convert to RGB, so I have to do that.
Just have a list of strings and then use two expressions to convert it.
Yeah, but for a list of strings, this will evaluate. So I will have to do a hold. Let's try just on this one.
Well, a list of strings.
I will have to do a hold, and we have to map at the level 2.
Yeah.
At level 2. And then I can unhold, and it should work. Okay. What? Oh, he actually evaluated the black before. Oh, okay, that's ridiculous. There's not enough. Let's do it. We do by hand. I don't care. We don't have time. If there was 100, of course, it won't be the same business. But I mean, unless you have an idea right now.
Parse the XKCD data set for colors. We have colors like light egg black.
Yeah. Okay, I'm over. So I guess I will do it because well, it's only 25. Yeah, okay, I will do it. So yellow goes to yellow. Okay, that's our training set. So we could do just one element per class, but machine learning is quite bad. I mean, the automatic machine learning is quite bad if you have a tiny data set. And one element per class, it will be hard because it will have hard time to cross-validate because it will use a training set and a test set. And if one element in the training set, it cannot be in the test set. So it will learn the yellow, and then it will ask orange. And of course, it will get wrong. Yeah?
Color data, HTML, color rules.
Could have said that earlier. All right, but are they? Oh, nice. Okay, that's a bit too much for our thing. But maybe maybe we try just this one. I'm almost over, and then we can do the cool one. But it's true. That's great. I mean, with that, you can actually do. Okay. This one is done. That's the data set, training set. So normally you should do add more examples. So the way to do that is that you would do modification. We do random colors, and there will be a curator that says this is red, this is blue, this is like your choice. And when you have that, you can use that in Classify. I don't have time to create extra colors, so I will just classify like that. But I won't let the Classify be automatic because it will be too bad, because it won't be able to do training set and test set with example of the same class in both data set. So here I will just do Classify and of the training, and I will just put a method in order for it not to try to do this cross-validation thing. So I just put nearest neighbors, and OK, and let's actually put this one that is not one of the color of our training set. And see what it says. It says it's brown. That's really weird. That's really weird. OK, what's wrong here? When you classify information. I mean, OK, when you have tiny data set like that, it's always a problem. You have all wrong things that happen. So it's a good. No, that's weird. Nearest neighbors there is not good enough. Yeah, you had to add more data. So, I mean, this one. OK, this one should be blue. Brown. OK, I'm going to look at the probabilities.
Nearest instead of.
Oh, wait. I classified with head.
Yeah, the head, exactly.
The head RGB. OK. So yes. So I will training all one to be equal to, and I will remove the head, so it will be all. What do I do?
You have to apply list. List at.
Reverse map, is it?
Reverse map?
Map reverse.
No, but if I do.
No, yeah, list at.
Yeah. OK. This would work. OK. OK, so we have our new training sets
Wait.
like this. Oh, where white is 1. That's ridiculous.
You use rasterize, Etienne. So you need to map rasterize across those, and then it turns into a picture.
But then, but I want the RGB thing.
Yeah,
So what is the thing?
before list, color convert RGB.
OK. So
Sorry, between list and training, yeah.
yeah, this is listable.
Color convert, yes, listable. Color convert RGB.
But you're going to be
Yeah.
doing pictures
Yeah.
of that. So you want to have
And we will color convert it. What's wrong with
Because they are not colors anymore now.
what?
You have redefined training goal 1.
Right.
Just
No. Oh yeah, of course. Okay. Good. Perfect. It works. Then we do classify training nearest neighbors, and let's look at this one. Oh dear. No. I didn't do it. This blue-violet is OK. Of course, I have to do color convert as well. So you have to do the same business and list and color convert because we will use it like this. So that's interesting. Any transformation that you do to the training set, you have to do it to your test set. So you have to keep this thing. OK, so it will be color convert, and then it will be list at. And here, purple. Yeah. OK, let's deploy it. Let's try it. And OK, for a picture now, what you can do is we need to have the dominant color of the picture. So this is pretty easy to do. So let's get an image. What? There's a color? OK. Up. All right.
turn it the other way around.
Anyway, so you can do dominant colors, and I will put 1 to have the dominant color, and it's this stuff. And then I can actually try it right now. What did he say for that? And he says gray. OK, I guess some kind of gray. And let's deploy all that. So now it's going to be form function. OK, this will put image, and it will be interpreted as, we call it picture like before. Now this is an image. I can do dominant colors of this image and take the first one. Okay. I have the color. I will use a module like before. I don't have time to use a code cell, so I will just up module, and this will be called color. It's important to put variables. I know that Steven enjoys not using variables anywhere, but he's wrong. You have to put variables. Otherwise, you don't understand what's going on. Because it puts a name, so you can. There's a name, you know what's going on, right? Anyway. So color, and now this color, we're going to apply our function there. And by the way, this is a picture, this is a hash picture, and then I will color convert to our color. And where there's a color here? No, okay. What's going on? This is a form function, %. Okay, I think that's it, right? Dominant color, you get the first one. Then you see, you can't see well when it's not in a code cell. You should really do that. Form function, first argument, a picture given image. Then a module, I will do indentation like this. This seed should grab from what it has before. And all right, and what do we do now? It will just return a name. It will just return the string, so we don't have to do PNG as a third argument. We can just let it like this. And OK, that's a form function. I will name it form. And I could try it, but let's deploy it directly. Cloud deploy, form. I will also put everything public. No, not C. Cloud object, we call it. C is a classifier that I should have named better, but OK. URL shorten of OK, and I'm going to try it straight away. It's almost the same as before. Cool. So it is, oh, no. OK, Wolf, oh dear. You can try it as well. It's public. 7ft. ftjy jhb b. Okay. Okay. So let's try it. All right. So okay, I'm in the morning and I'm colorblind.
Do the inside.
And what?
The inside is better.
Flip your coat.
Oh. Do we better? No, but we won't risk it. No, I'm kidding. I want it to work. OK, that's a picture. And I say OK. And I click submit. And let's see. It's green. It's a bit yellow, huh? I don't know. I'll be happy with yellow as well. Come on. OK, I guess, OK, maybe, I don't know the resolution that he tried to send. Why? OK. Let me press submit again. Yeah, my phone internet is actually quite bad as well. So, does anyone have a good phone and put the URL and want to try it?
Mine says that my face is pink.
Which is.
Pretty close. You could wrap it in like image resize to get a smaller image.
Probably, yeah, you're right. But I don't know. I don't know actually if it sends directly. Oh dear. Okay. Let's do again. Up. Camera. Okay, I want to take a picture. Taking a picture. All right. And now submit. What time is it? Oh, we're a bit over. Yeah, we're a bit over time. So maybe let's just finish this one, and then the next one you can do it for yourself. Is you can use Wikipedia data to get some text, and do a classifier with text. So you get a bunch of. I mean, you get the biology page. I mean, I don't know, maybe the physics page, and maybe this will be the science, and then you get I don't know, the Barack Obama page and John McCain, and you create that to have the topic, and you do a bunch of them, and you see what's happening. Okay, my internet is not good enough to send the picture, which actually I should just change the resolution of the picture when I do it. Okay, let's do it again. Up, camera, and here my setting. Maybe I shouldn't lose time with that, but. If someone has a thing that works, maybe they can show everyone. What can I take? Oh, Android is such a bad software.
Yeah, Etienne, I think we're 10 minutes over. So.
Okay. I can just show you something then that will last 2 minutes, or 5 or 10, but it's going to be fun. So it's something. It's an application that learns how long you're going to wait in a line. So it's a restaurant that would use an application like that. I mean, as you know, in the US, they always make you wait in a line. And so here, I do cloud put to just put an association that would be my data structure representing my queue. This is a training set that I generated myself. So you can see that as a past data. And I also put this training set in a cloud object. So now I have the queue somewhere, the cloud object somewhere. I'm going to do a form in order to add somebody to the queue, okay? So this form is form function that has a bunch of things. You can put a phone number, things like that. This is not required, the phone number. And what it does is that it gets the queue, and it adds somebody to the queue, and it put back the queue, okay? So this is the form, the add form to add stuff. So let's do it. I'm going to add someone. So, okay, so I add Bob. Bob is with 3 persons, okay? And I submit, and it's add somebody, and I'm gonna add somebody, Alice 5 person. And I don't bother to put the phone numbers, but you could as well, and then the application could maybe send an SMS or something. And then you have, what's another name? Claire, she's my sister. And Claire is with her boyfriend. She's single, by the way, right now. But okay, now let's look at the queue. And so I do cloud data set just to visualize. So okay, you have the persons. It's stored the day. So we are Thursday. So it's all the things that, of course, the thing knows. You just have to do now. And day name. It stores the time. Just store it in Unix time. Okay. Phone number. There's nothing. This is a history. So this is something as a queue go along. Each time I update this history. Like when was this person waiting when there was only 1 person in front of, 2 person in front of, blah, blah, blah. This, I have the drop form, so the form to drop somebody from the queue. And when it drops, it does a bunch of things. So, I mean, that's why an exercise that I couldn't have done here is that it computes the time that if effectively, the group effectively waited, and then it add that to the training set. So this is an application that continuously learns, okay? You add that to the training set, and then perform predict on this training set. And that's one of the advantages to have something that is completely automatic, is that you don't know what you're going to have. You create an application, maybe a restaurant will have a lot of people, maybe they will have some other characteristics to the people, like the group, maybe they will have some other things, like, I don't know, what kind of characteristics they would add. The coder doesn't need to know about that, just you predict, and it will predict always something supposedly decent. And then I put this cloud form, I put this predictor somewhere. And okay, let's look at the drop form. Let's remove somebody. And okay, let's remove. Who do we remove? Remove Claire. She just broke up. And actually, anyway, so this you remove somebody from the queue, and I could look at the queue again, and normally Claire should be removed, and the training set will be augmented. If we look at the training set, we should have, okay, Claire is gone, and the training set should have one more example. And then you can visualize the object. So this is the URL that the user would have. And what it does is that it gets the predictor. It does prediction on the feature, like how long have you been waiting, how many people you are, basically. And it converts to second, whatever, and it plots a nice distribution. It's very geeky. That tells you your distribution on how long you're expected to wait. So Bob is supposed to wait 3 minutes. That's the most likely value, but you see that it's actually quite wide. And if you actually end up spending 10 minutes, it might not yell too much. So, yeah, you see, there were some probabilities that you would wait 10 minutes. And this might seem stupid. You might say, oh, we don't know the table in the restaurant, if the table of 3 person, 5 person, Like, you don't need to know, because the thing learns. The thing learns that when there's somebody with only 2 persons, it happened that at this time, when you're 2 persons, it goes quite fast. So you can improve, but even without any assumption about the restaurant, I didn't try it on a true restaurant, but I'm ready to bet that it does a pretty good job. Probably better, and this you should compare, because you can ask them and they give you a time. And you compare, you can do a control experiment to see if the time they give, and they know perfectly the restaurant, they're there every day, is better than the learner. And I'm ready to bet that the learner, maybe not a lot of money, but does better than the expert in the restaurant.